Okay, here we are, continuing our discussion about parallelograms. So before we were spending lots of time with triangles, now we're spending lots of time with parallelograms. Alright, so this one right here, we want to talk about some other properties of parallelograms. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Basically, what you're going to notice here is that this stuff is all almost just the opposite of what 6-3 was. So if you know this and this, then it's a parallelogram. The next theorem says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So, as an example, so here we have A, B, C, D. So angle A is sup to angle B and angle C, then ABCD is a parallelogram, okay? Theorem 610 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this one's saying if this congruent, then parallelogram. This one says for what values of the figure will it be a parallelogram? So this one, it's a lot easier to, if you stick with the consecutive angles, you'll only have one equation, you'll only have one variable, so it makes it a little bit easier to solve. As opposed to if you do the opposite angles, then you end up with two variables, and it makes it a little bit harder to solve. It actually doesn't even work. This is a weird problem. It doesn't work. But anyway, so I have these, if it's a parallelogram, the consecutive angles are supposed to be supplementary. So these two should add up to 180, these two should add up to 180. If you notice the way I set it up, it's going to work out nicely because then I'm not going to have anything that I just have y over here. So then I get those two answers for x and y. The next one says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram again. So if these are bisected, then it's a parallelogram. Okay. Proof time! So I'm proving this theorem up here. So I'm not going to use the theorem, I'm proving it. So it says AC and BG bisect each other. So if they bisect each other, then AE is congruent to CE and BE is congruent to DE. So that's definition of a bisector. So then I know this one here is congruent to this one right here is congruent to this one. And then I also know that angle BEA is congruent to angle DEC because of the vertical angle theorem. And then I would know that triangle BEA is congruent to triangle, DEC. I said these angles are congruent because side angle side. And then I can say here that BC is congruent to AD, and I can say that BA is congruent to CD because of CPCTC. And now if I'm saying that this is congruent to this, and this is congruent to this, then AB, is it 7? No, 6. ABCD is a parallelogram, because back on the other page we said that if opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So opposite sides congruent, then parallelogram. If one pair of opposite sides of a quadrilateral are both congruent and parallel, the quadrilateral is a parallelogram. So what this one is saying is if you have a pair that's parallel and congruent, then it's a parallelogram. All right, these are not full-blown proofs here. In this one, we've got these sides congruent, and then these sides parallel. So we don't know if it's parallelogram. So we can't do that because, or at least not straight up, right? We don't have enough information there. And then this one says this is congruent to this one. So if those two are congruent, then this is parallel to this. And if these two are congruent, then this is parallel to this. So yes, this is because the opposite. So yes, this is parallel because opposite sides are parallel. Okay, you can see here that we got some proofs in this homework. Once again. And I don't know. I'm just looking at these problems. This one, if you solve y first, it should be pretty easy. I think that you should be okay with these ones. So I'm not going to do any of these ones. All right, so that's it for lesson 6-3.